I guess you have already figured out vectors have a lot of information, so here is a lot more information for you today. Let's talk about standard unit vectors. Remember, a unit vector we learned from Friday has a magnitude equal to 1. Okay, we found out how to find unit vectors, and today we're going to look at some standard unit vectors. So the standard unit vector uses the letter I and J, and they're positioned along the x and the y axis, and they are defined. I is 1 and 0, and J is 0 and 1. Because this is 1 and 0, we know this is on the x-axis, and because this is 0 and 1, we know this is on the y-axis. And you can see on the picture here, this is your standard unit vector I, and this is your standard unit vector J. You've got the positive x and the positive y-axis, okay? So any vector, v, that's a and b, can be written in the form ai plus bj, where a and b come from the component form, and then I and j are going to be your standard unit vectors, I and j. Okay, this is called a linear combination of vectors I and j. Think of a linear combination. When we think of combining things, we think of adding them. So the basic form, again, is ai plus bj. And you can take any vector that you're given and put it in this linear combination form by taking whatever you have in the first spot and multiplying it to I, and whatever you have in the second spot and multiplying it to j. Now, what follows is just a proof of this, where you take and rewrite this as a sum of two vectors, where v is a and 0, and then right here, 0 and b, and then factor out your a and your b from each component form, and that will leave you with 1 and 0 and 0 and 1. And then you can replace 1 and 0 with I, and 0 and 1 with j. And again, that's just proving from going to component form down to linear combination form. So on this very first problem right here, where it says rewrite each vector as a linear combination of I and j, this is your vector 2 and 5. So the first thing that you want to do here is just simply write down v, take what's in the first part of your component form and multiply it to I, take the second part and multiply it to j. And it's really just that simple to write something as a linear combination, okay? So this is your vector in component form. This is your vector as a linear combination. Look at number 3. Okay, we have RS, okay, this is our vector form, this is my initial, this is my terminal, and we want to write it as a linear combination. Well, before we can write it as a linear combination, let's go ahead and write it in component form first. So remember, when we do that, what we need to do is we need to take our values and we need to do terminal minus initial. So to actually get the vector RS, let's do terminal, which is -5, minus initial, -5 minus a -9. Then let's do it with the second part, which is -6, terminal minus initial. Okay, so that tells me that my component form will be -5 plus 9, which is 4, -6 minus 8, which is -14. So I've written it in component form. Now let's write it as a linear combination. So 4 will be multiplied to I, and then plus -14 multiplied to j. So my component form is 4i minus 14j. Now, over here on 2 and 4, these are the two that I would like for you to do, putting component form as a linear combination and putting it in component form and then linear combination. All right, now the second part tells us that if u is a unit vector, then the terminal point u lies on the unit circle, because what is the radius of any line on the unit circle? It's 1, okay? So if a unit vector has a magnitude of 1, it makes sense that it should lie on our unit circle. So if u is a unit vector with the terminal point of u lies on the unit circle, therefore u can be written as, we know on the unit circle that all of our x values are cosines and all of our y values are our sines. So we can change a to cosine and we can change b to sine. And if we want to take this component form and write it as a linear combination, we can do the cosine of theta times I plus the sine of theta times j. So if it's a unit vector, it's going to be on the unit circle because its magnitude or length or radius is equal to 1. And we know all of this information from our unit circle. This is your cosine. This is your sine. And then to take component form and change it to linear combination, you change it into an addition problem with I and j behind your x and your y. Okay, and now let's leave this to you to check out on the picture. All right, let's get some more notes in here. Okay, because every vector v is the product of its magnitude and its corresponding unit vector, we can write v in the following forms. Okay, the magnitude times the component form, cosine theta, sine theta, which can also be written using the distributive property here in your component form, magnitude times the cosine, magnitude times the sine. Okay, and now we know we can change our component form into a linear combination by taking magnitude cosine, multiplying it times I, and adding it to magnitude sine times j. Now, this is your final way of writing that out. Your book in section 9.4 actually writes it like this. I usually see it written more like this than I do this, with the magnitude and then cosine, and this is your theta. They've replaced in theta with this symbol in your book, and then plus sine j. Okay, and that way you can just find these two values and distribute your magnitude whenever you need to. Okay, so this right here, write that down, or write this one down, write one of them down and commit it to memory so that we can, this is actually called our trigonometric form of any vector. So this is your trig form of a vector. All right, let's look at the next page and see what else is up. Okay, so now that we've gotten all this information, okay, we've got find the component form of each vector with the given magnitude and direction angle. All right, so let's use our formula we just had. Okay, V equals. Now in component form, the first thing that we had was the magnitude, which was 8. And we're going to multiply it times the cosine of our direction angle, which in this case is going to be 60 degrees. Okay, and then the second one would be our magnitude times the sine of 60 degrees. Okay, so this is component form, and it asks us to write it in component form. Now, from our unit circle, we already know that the cosine of 60 degrees is equal to 1/2, so I can replace that. And we know that the sine of 60 degrees from our unit circle is the square root of 3 over 2. So 8 times 1/2 is actually equal to 4. And then here 2 will go into 8 4 times, and 4 times the square root of 3 is 4 square roots of 3. So I have taken my magnitude and my direction angle and I've plugged them in. Now when you're looking at this formula down here, I use this one to just, or this one right here to plug in just now into component form. Theta is your direction angle, okay? It's going to be between the x-axis and the terminal side, which will give you the direction angle. So that's what we're talking about here when we say direction angle. So what I want you to do is to complete 6, 7, and 8. Now on 9 through 14, it says write each vector in trigonometric form, okay? Trigonometric form is wanting us to leave the cosine and the sine in the problem. So let's see what we can come up with here on this next one. So on number 9, it's already written in component form. So let's go ahead, and we need our magnitude and we need our direction angle. So to find the magnitude, okay, remember we'll take the square root of 15 squared plus 8 squared. Now the square root of 289 is 17. So we've got our magnitude, okay, or the length of our vector. Now let's find our direction angle. So the tangent of theta is equal to, remember it's b over a, or 8/15. So let's find the inverse of 8/15. Let's go to our trusty calculator and do second tan of 8/15. That's going to give us 28.1 degrees. Okay. All right. So now in order to write this in trigonometric form, let's do V is equal to our magnitude times the cosine of 28.1. And then the second one will be 17 times the sine of 28.1. Okay, so this right here is writing this out using sine and cosine. Now you can write it like this, or you can pull the 17 out as a GCF, put the magnitude in the front.
So what can you
And that will give you your final answer.